Okay, welcome back to Quick Concepts. This one's going to be area, but it's going to be a little bit more complicated area, so I'm going to just call it area part 2. So on the last video, on the last quick concept that I did on area, we just focused on just general area, like area of rectangles, squares, circles, triangles, things like that, where and maybe if you have multiple shapes in one. Well, now we're going to do area of shaded regions. Before we do that, I do want to introduce one more area that I have not talked about yet. It's called area of a sector. So what does that mean? Well, a sector is essentially a chunk out of a circle. So if I wanted to know the area of this sector, what I have to know is how many degrees this angle is. So let's say this is a 40-degree angle and my radius is 5. The area of a sector of a circle, which is this, would be whatever degree over 360 times pi r squared. Okay, so the only difference between the area of a sector and the area of a circle is that degree that we're taking out, that pi piece, that chunk. So this would be 40 over 360 times pi times our radius squared. So one of the biggest problems I see that students run into is really how to input things into a calculator. So I want you to understand that all that is saying right there is 40 divided by 360. So what I'm going to do is I'm going to grab a calculator. I'm going to say 40 divided by 360. And you get like 0, is that right? 40 divided by 360. 0.111, something like this, pi times 25. So if I needed to put this into a calculator, I would say 0.111 or 40 divided by 360 times pi, and you can just hit that pi button on your calculator, times 25. So this is going to give me the area of this sector to be 8.73, and let's say it's in centimeters. And I'm going to say centimeters squared because it's still an area. So I wanted to touch on that, but what I really want to get into is area of shaded sectors or shaded sections. So in Saxon, you run into some problems that look something like this. Let me get one that maybe isn't as, yeah, let's do this one. This one looks a little complicated. So we have a circle here. And this is going to come across like this. And we have triangle here. And then we're going to say this and this. Now let me shade in what we have. So this is the shaded part. This is the shaded part. This is the shaded part. This is an actual problem in your book. This is like from problem set 1, number 5, if you needed help on that particular problem. And this right here, just so you know, is 60 degrees. I'm just going to write that in. Oh, Christmas colors. Okay, so essentially what we have here is you've got a circle with like a triangle taken out of the top and then a sector taken out of the bottom two portions. But let's divide this up. Let's divide it up to this. And I'll explain why I'm doing this in just a second. So this area plus this area. Okay, and the reason that this makes this a little bit easier, because if you think about what's going on here, this is the area of a semicircle minus the area of a triangle. And this is actually just the area of a sector. So do you see, like at first it looks extremely complicated, but then if you take a step back and you say, well, wait a minute, what do I know? So the area of the shaded region is equal to the area of the semicircle minus that triangle, because that triangle comes out, and all I'm left is those little two halfy pieces. And then I'm adding it to the area of sector on the bottom. Well, we can do this because we've gone over each of these sections. The area of a semicircle is pi r squared. The area of a triangle is 1/2 base times height. And the area of a sector is whatever degree you're dealing with over 360 times pi r squared. So let's actually put this in and see what we have. So let's go ahead and put in our numbers. So the radius here, remember it's halfway across the circle, is 4. The base of the triangle is this whole thing, and that's 8. Now don't let the height confuse you. It's going to be the same thing because it's a radius. So that's times 4. The degree we're dealing with is 60 over 360. And again, we know the radius because we've used it. So now let's go ahead and see what we have. We have 16 pi minus half of 8 is 4. 4 times 16 is 16. 60 divided by 360, just put it into your calculator. You can use the fraction, but you don't have to. You can say 60 divided by 360 is 0.167 times 16 pi. So I'm going to go ahead and put that in, and then times pi. So this right here is 8.38. And then we have 16, and then 16 times pi is 50.27. So 50.27 minus 16 plus 8.38 equals 32.65. And those are that's going to be our answer there. And we want to look and see what units, and this unit is in centimeters, and it's centimeters squared. So again, this is just area of shaded regions, and it can get a little complicated. Number 6 on that same lesson, lesson 1, is another one that's really kind of crazy looking. So I'm going to go ahead and do this one for you. All right, so this has got a radius of 4. I swear I'm not an artist, so this takes me a little bit longer than most. This is well, that's 3. It's a right angle. And then this last one is 5. Okay, now for a minute, if you need to see this, this is on page 25 in your book. It's lesson 1, number 6. So I want you to take a minute and kind of look and see what's going on. If I wanted to know what's in the shaded region, let's think about it. I have the area of a semicircle that's pretty large minus the area of a larger triangle plus the area of a medium-sized semicircle, that would be this guy right here, minus the area of a medium-sized triangle plus the area of, oh goodness, kitty, my cat is sneezing. I don't know if you can hear that, but it's really loud. Minus the area of a small triangle. And then lastly, you got to add that area of that triangle in the middle. So really what we've done is we've taken this really complicated looking problem and we've broken it down into something a lot easier. So let's go ahead and do this. This is going to be pi r squared divided by 2 minus 1/2 base times height plus pi r squared divided by 2 plus, or excuse me, minus 1/2 base times height plus pi r squared divided by 2 minus 1/2 base times height plus the area of the middle, which is just a triangle, 1/2 base times height. So now we're going to replace these things with numbers. So let's look at the large triangle first. Based on this, we can see, first of all, the radius is going to be 5 because of the placement of the triangle. And the base of the triangle is 5, and the height of the triangle is 5. Now let's go to the middle one. That radius is 4, and that's going to be 4 times 4. And let's go to the small. And then lastly, we have to kind of extrapolate from the middle what's going on. If this is 4 here, and this is 4 here, and this is the right angle here. So this height is going to be 3 and 3, which is 6. We would say 1/2. The base is 8, and the height is 6. So now at this point, it's all algebra. Geometry is gone. We don't need to know any more formulas. We just need to carry out our work. So this is 25 pi over 2 minus 5. No, minus 25 over 2. Plus 8 pi minus 8 plus 9 pi over 2 minus 9 over 2 plus 24. And guys, I would just grab your calculator. There's no need, 25 times pi, there's no need in trying to do this divided by 2 minus 25 divided by 2. So this little guy right here is going to be 26.77 plus 8 times pi minus 8 equals 17.13. 9 times pi divided by 2 minus 9 divided by 2 is 9.64. And we can see it gets smaller, which is good. So now we're just going to add these all up. So it's 26.77 plus 17.13 plus 9.64 plus 24. And my answer is going to be about 77.54. And the dimensions are in centimeters. So there's just an example of a couple more complicated problems that you might have to do in the area of shaded area. Haha. And that is it.